Okay, welcome to this overview having to do with academic honesty in CSCE 430. Now, the reason that we are going through this is to try to give you a better understanding of exactly what's allowed and what's not within this class and make sure that those boundaries are clear. Now, hopefully the reason you're taking this class is to be able to improve your own skills, to become a better programmer yourself, to become better at analyzing problems and solving them and understanding when different algorithms apply and how to write test cases and that sort of thing. And as a result, everything that you're doing in this class is going directly to that goal. And so anything that you do that's going to get around that, any form of cheating that you might undertake is really going to counteract the entire point of taking this class. And so I just say, if you're considering cheating, think about, why am I even in this class to begin with? You're completely counteracting the point of the class if you're getting around the programming and problem solving and that sort of thing by copying it or looking at it. Now, the other thing is, this class, it happens to be particularly easy to cheat in. It's easy to find online sources. It's easy to talk to other people and collaborate on problems in ways that you're not supposed to and that honestly are kind of difficult to detect, although I'll just say not impossible. And as a result, I need to spend some time to make sure that you understand where the right boundaries are. In this class, some things are okay to use and some things are not. So I want you to understand some of those boundaries. We're going to go through two parts of this, one having to do with working with other people and one having to do with using online resources. And that'll be in kind of two different parts, and I'll give examples of each one. Now, as a result of it being relatively easy to cheat in this class if you want to, what that means is, if I do catch you, I'm going to be especially harsh with the penalties because I'm really relying on an honor system a lot in this class for you to approach the problems. And so you should expect nothing less than an F star if I do happen to find a case of cheating in the class. So please try to avoid that. I will say I've given F stars just about every semester I've taught in the course because I've had to do so. I've found people doing things they weren't supposed to, and please don't let that happen. It's one of the things I hate the most is having to follow through like that. There is going to be an acknowledgement that after you have watched this video, that you go into Canvas and you fill out a little quiz just basically saying, yes, you understand the main points from it and that you've actually watched the video. There's also the acknowledgement for Caddis in Canvas. Okay, so just in terms of general principles to follow, if you remember, we have two periods of time. You have the problem-solving time when you'll be working on problems. In lab, that's during the lab time, during the timed lab period. For the weekly problem sets, that's during the week that they're assigned before they're first due. And the purpose of this is to show that you can analyze a problem and determine a solution and test it, and that you can do all the different aspects related to the problem. And so that means that you need to determine how to solve the problem on your own. When you're getting a grade on that, basically every single one of these problems is your grade. And that is supposed to be demonstrating that you were able to come up with the solution on your own. And you should also be writing the code on your own. Now, during the upsolve period, that's the following week, so the week after lab is over, or the week following the time that the weekly problem sets are due. The goal of that, and the reason you only get half the credit, is to show that if you already understand how to solve it, you still can code it up and make sure that your code is working. And so in this case, the rules are a little bit different. You are allowed to collaborate with other people in terms of understanding what's there, but not in terms of writing the code. Actually, writing the code and getting it to work is still something you should be doing. So, one aspect of this has to do with what is and is not allowed as far as collaborating with others. So, again, the basic general principle is, during the main period of time, you should be doing it by yourself. So there's not a whole lot that you should be doing with other people beyond the idea of understanding what the problem is actually asking. So if you haven't solved the problem before, you probably shouldn't be looking at someone else's code. If you've already solved it, then you should be really careful about what you talk about with other people and not tell them how to solve it. So be very careful in your discussions. Now, if you don't understand the problem, you're trying to actually like figure out what it's saying, and perhaps if there's sample data or something you just don't understand what it's showing and why it's working, that's the sort of thing that's fine to talk with other people about, to actually understand what is the question being asked, what is it trying to get to. But you should not discuss the actual way to solve the problem, at least during that first period of time. Now, once you hit the upsolve period, it's fine to talk about how to solve it. It's fine to say, this is the algorithm you need to use. You need to check for these test cases and that sort of thing. So even in that period, you shouldn't be looking at other people's code. So just look at your own code. Don't look at other people's code. Now, I'll say there is some common sense involved here. If you have issues having to do with like a language, like, hey, how do I, does C++ have something that lets me handle set operations? And you ask someone about that, that's fine, even if it's needed to be used for the problem, because that's something that has to do with the language itself. I will even say that occasionally you run into debugging issues where there's like some little bug and it's not like going to the solution of the problem, but you're pretty sure it has to do with like using a function call wrong or something like that, and you're saying, wait a minute, this is not behaving right. It might be okay to get a little bit of debugging help with that sort of thing from other people. And if you have a syntax problem or you need some aspect of the language. So I'm not trying to say that you just can't talk to other people, and pretty much everyone knows, yourself, if what you're doing is likely to be crossing the line beyond I'm just getting help with the language to I'm actually getting help in figuring out the solution itself, or having someone else write it. So in order to clarify this, I'm going to go through several examples and sort of ask you to think about them. And if you need to think about it, just press pause and you can think about it, and then I'll go through the answer about what is and is not okay as far as working with other people. Okay, so imagine person one says, we're supposed to read in coordinates. Do we need to handle floating point numbers or just integers? And person two says, I just read in integers and it worked fine. So does this seem to you like something that's okay or not? Well, this is probably okay because it goes to understanding the problem itself. If the question is, wait, is this integer input or floating point input? That's something about the problem. It's not really about how you solve it. Now, if you go into something like, oh, you need to make sure you use double precision floating point instead of single precision, or you need long ints instead of something else, that starts going to the problem itself. But just make sure that you're saying, look, the problem says you need this. That's fine. Now, probably a better answer is just read the question, because the question should have specified exactly what's needed. Okay, here's another conversation. Person one says, is this one we're supposed to use a dynamic programming approach for, or does a greedy approach work? Person two says, oh, you need to use a dynamic programming approach. The greedy one won't handle all the cases. Okay, that is not okay during the problem period, during the main period, because that's talking exactly about how to solve it. It's telling you the type of algorithm you need to use. And it's not really going to what the problem is asking, it's actually going to the solution method. Now, during the upsolve period, this is totally fine. You're allowed to talk about what is and is not allowed. Okay, another conversation. Can you look at my code and see why I'm not getting the total number correct? Person two says, you're double counting some cases. You need to make sure you're counting each solution only once. Okay or not? Well, this is probably not okay, because this seems to be asking someone to look at your code and tell you if your solution method is right or not. And the response is talking about how to solve the problem. So it's very difficult for me to see any circumstance where this would be okay, at least during the main period. Now, during upsolve period 2, if person 2 had already solved the problem, it might be okay, because you're trying to say, am I solving this right? Now, person 2 should still be making sure that they're just giving help with like how to solve things, or like some small debugging things, rather than, oh, here, you need to write your code this way. If you ever get to the point where where you start thinking, oh, let me tell you what lines of code to write or exactly what to write, then that's a problem. Okay, another one. Can you look at my code to tell me why this angle computation isn't working? I take sine of 30 and it's wrong. Okay, and the other person says, oh, it looks like you need to convert from degrees to radians. Okay, now this is actually probably an okay thing to do. It might seem weird. You don't really want to be looking at other people's code. That's not the right thing. But the problem is really dealing with the language feature. Like, why is sine of 30 coming out to be the wrong number? I know that the sine of 30 should be 0.5, and it's coming out at, like, I don't know what it would be, -1 or something, if you forget to convert degrees to radians. And so you need to make sure that, like, if you're asking a question like this, it really is going to a language feature rather than something that's a fundamental solution method. Now, if the person had answered something like, oh, you don't want to compute the angle, just use the Pythagorean theorem, that's not appropriate because that's actually going to the solution method, although even that would be okay if it were the upsolve period. Okay, another conversation. How do I check for end of input when I don't know how many lines to read? And person 2 says, if you try to read a line, you can check whether cn.eof is true to see if you've read to the end of input. And that's okay. That's a general language issue. That's just talking about, like, how does the language work? How do you check for end of file? It might be needed for the problem, but it's not the point of the problem. That's not really going to solving a problem. That's going to how a language works. Okay, another conversation. I don't know how to code up Dijkstras algorithm. Person 2, here, I've coded it before. Let me do it for you. Well, obviously, this is not okay. Now, there's sometimes we probably won't do it with the social distancing that we have this semester, where we have team programming. We'll see. We might still try something. But unless it's a team programming thing where the two of you are working together, in which case everything is okay, that's the only circumstance this would be okay. I can't even imagine why you would think it would possibly be okay otherwise. Okay. And this is another one. I'm trying to create a pair of pairs, but I keep getting a compile error. Do you know what the problem is? And the other person says, oh, you need to have an extra space in between your closing brackets so it's clear you're ending a template, not writing a stream operator. Or you could say, be sure to compile with C++ 11 standard. And that's okay because you're going to a basic language function. And if you're wondering what I'm talking about, if you like make pairs of pairs, and as you see there in the red, if you put your brackets the wrong way, certain versions of C++, the earlier standard, would interpret that as a stream operator rather than as two separate closing brackets and throw an error, although that is fixed in later versions. Okay, one more. Hey, I solved problem C. That was tricky. Person 2 says, I've been trying, but I keep failing on test case 4. Person 1 says, oh, that got me too. Make sure you're handling the case where the input is 0. Okay, so that is not okay during the main problem time. Now, during the upsolve time, it would probably still be fine. Because this is going to a specific test case that causes things to fail. So the best response would be to just say something like, oh yeah, that got me too. And something that's kind of borderline would be, make sure you're handling edge cases. So it's probably better not even to say that. Let them try to figure out that they're missing an edge case. But at least you're not saying exactly what the edge case is when the input is 0. So this is the sort of thing, it's very easy to slip into doing this. Don't do that. Just try to keep things generic. Like, yes, I had trouble with that too. Oh, it was a challenging problem. Not, oh yeah, I can't believe I forgot to do A, B, and C. Because that's basically telling someone how to solve. Okay, so hopefully those were helpful and clarified a little bit about what's allowed and not allowed in terms of working with other people. Now let's talk a little bit about online resources that you might have. So since problems are public, so we're using the Caddis system, these problems are publicly available. And what that means is in several situations, you might be able to find a publicly available solution to the problem. Just like if you have a textbook, you might be able to find online solutions to textbook answers. And let me just make it totally clear. It is not okay to look at other people's solutions to problems. Okay, if you ever go out and you say, here here's a problem. I found someone who solved it. I'm going to look at their code and just see how they did it. I'm just going to learn from them. That is not okay to look at. Okay, not okay. Just don't do it. Chances are, if you look, you can probably hunt out and find people who've solved many of the problems that we have. Now, you shouldn't ever look at these things, I will say, unless the entire problem is done. Like after you've solved it and submitted it and got it right, and you want to say, how did other people do it? Maybe you could do that sort of thing, but it's not okay to do before you've turned it in. The other thing to think about is there are sometimes that you'll have a problem and you say, oh, this is identical to a different problem. It's not the exact same one, but it's identical to it in every way that there is, other than maybe a slight adjustment on the input and output. No, it's not okay to just copy that code or look at that or use it either. Okay, and you probably shouldn't even be looking at it. Although, if it's something generic enough, maybe on a really simple question. Okay, so what is okay to look at? So we talk about the textbook in the class, and just because it's a textbook for the class, I will let you use code that is in the textbook. It's not ideal. I would still rather you write your own code rather than just copy stuff that the textbook has, but if you have something from the textbook, you can use that. If I have stuff that I've gone over and done in class, when I give an example in class and code something up, and if you want to use that code, you are welcome to use it. Again, it would be better if you wrote your own. If you have a description, now I'm not talking about the code, the description of a general or a generic algorithm, it's fine to look that up. So if you're like, I don't remember how quicksort works, and so you go read about how quicksort works, and there might even be, some generic code there for it, that often if you find a description, there will be at least pseudocode for it. So it's okay to look at general algorithms like, what is Dijkstras' algorithm? I've forgotten it. You go and you look up what Dijkstras' algorithm is. Now, as far as code for general algorithms, I would rather you not use it. I would say that you should never, this is just like a good habit to be in, never use someone else's code unless you've coded it up yourself first. And this is something that people sometimes argue because they'll say, well, hey, when I'm doing something in industry, I'm going to use other people's libraries or I'm going to use other people's code. I'm not going to write everything myself. And that's true. But guess what? You're not in industry. You're in a university. You're here to learn. And the reason that we are having you do these things is to help you learn. And just copying someone's code and using it doesn't necessarily help you learn it. If you actually go through the process of implementing it yourself at least once, then you can make use of that later on. You've at least gone through the mental process of having to code things up once. Now, if something is generally provided in a language, like if you're using the STL in C++, that's fine to use that. There's generally, there's algorithms and stuff that are built into languages. It's fine to use those. In fact, I would encourage you to do so. There's no reason not to. Okay, so we'll go through some examples of this. Oh, sorry, one other thing. If you are using external resources, a couple of things I would say. First of all, if you are wondering, hey, is this okay to use? Check with me first. Don't just assume it's okay unless it clearly fell into one of those okay categories that I mentioned. And also clearly cite where you got them from. And what I mean by that is don't hide it in the code where no one would ever see it. If you put it prominently in the code, like this function was pulled from here, I'm using the generic Dijkstras algorithm that I got on X. I will say I will not report that as an honor code violation as long as you have cited where you got things from. So if you always cite where you got it from, I'm not going to report you as an honor code violation. I might sometimes say, whoa, you just copied too much. I'm not going to give you credit for the problem. That would be the most I would do in that case. And probably not even then, but that would be the most I would do. If you are wondering, though, check with me first. Okay, so now to examples. So you say, I found someone's GitHub where he posted his solution to that problem. I just used that. Do you think that's okay? Well, no. Hopefully it's obvious that that is never okay during any period of time, including the upsolve. And I'll just point out, because some people get confused about this, just because something is available online does not mean it's okay for you to use it. The legal issues about using other people's code just because it's you can find it publicly doesn't mean it's okay to use it publicly. Okay, then another example. Problem was from the 2018 ACM ICPC World Finals. I found a presentation describing the problems from the finals, and I read through that. Okay, that it described how to solve each one. So that is not okay during the initial assignment time, because it's basically telling you this is how you solve this problem. Now during the upsolve period, that would be fine to do, because it would just be describing how to solve it. Now it's not okay still to find a solution to it and use that, but it's okay to find something that talks about how to solve it. And by the way, we will be talking about how to solve these things in class, so hopefully you won't have to go to other resources. Someone says, I didn't look at the problem solution, but I found some test data that could be used for the problem, and so I used that. Well, that's not okay. Part of the point of this class is for you to come up with the test data yourself, to think about what are the test cases that are good enough to actually use on the problem. Now, during the upsolve period, it's fine to talk about the types of test data that you might want to use, but you should still write the tests yourself. That's part of the goal of this class, even during the upsolve period. Okay, next thing is I used the suffix array code that's in the book to solve the problem. Well, I said before, stuff from the textbook is allowed. However, you should make sure that you understand how suffix array is working, and I would really encourage you to code things on your own from the description before you start just using someone else's code. Okay, now what about you say, well, I didn't look at a solution for that problem, but I found a problem on another site that was nearly identical, and I used that code and I changed the output lines to match the format. So no, just because it wasn't the 100% identical problem doesn't mean you can copy the code from somewhere else. So you will find sometimes nearly identical problems. Not okay to just copy and use that either. Okay, what if you say, well, I implemented Dijkstras back in 221 and I used my implementation of that to solve this problem. And yes, that's okay. For one, Dijkstras is a general algorithm. And also it's something you've implemented before, so it's fine to use that. Okay, so then you say, I knew this was the depth first search problem, so I looked at a website that showed how to do depth first search. And yes, this is fine. You're looking up how to do a general algorithm. So these are general algorithms. You're looking up the general method of how they work. Now, that doesn't mean that it's okay to just blindly copy code from the website, but it's totally fine to, in fact, I'd encourage you, if you don't remember how something works, to look it up and learn about it and remind yourself of how these things work. Okay, what if you say, I solved a really similar problem on my own a year ago. I just copied that code and modified it for this program. And that's okay. You wrote the code. It's your code. There's nothing, I'm not saying that you can't use previously written code that you wrote. I will say it's not the best practice. If you've solved it before, you can probably solve it again, even if it's the exact same problem. So I would encourage you to go ahead and try writing it again, but it's not a violation of any rule if you use stuff that you have written previously yourself. All right, what if you say, well, I found an online implementation of the max flow algorithm, and I used that in solving this problem. And so, no, you should try coding things yourself. It's not okay to just copy code from online. It's not okay to just say, oh, here's this default algorithm, I'm just going to copy it. Implement it yourself. That's what you should do. Now you say, I found an online discussion of max flow, and I followed that to write my solution. Well, yeah, that's probably okay, because that's going to how the process works. How does the max flow approach work? And so if you look up general stuff online and you write your own code based on what you learned, that's great. That's not a problem. Just blindly copying code is. Okay, so to summarize, the goal of all of this, the reason that we spend almost half an hour going through all of these topics, is that I want you to understand that the point here is for this class to teach you how to approach a problem, figure out how to solve it, implement it, and test it. And that's what all of these problems are about. And if you get around that, either by looking stuff up online or talking with other people to shortcut that process mentally, you're creating these shortcuts that aren't going to help it go into your own mind. You're not going to learn how to do it yourself. If you can't figure out how to solve it, you just don't know how to solve it, well, that's what the upsolve period is for. If you don't figure it out, that's what upsolving is for. And so don't cheat. Just do what's available. And if you find I can't even code it, I can't figure out how to code it, even if I know how to solve it, well, then guess what? You shouldn't have credit for that question. That's what that really means. It means that's not a question you deserve credit for. So it's not okay to just get credit for it anyway. Okay, so now all of this, you do need to use some common sense. I'm not trying to say don't talk to other people. I encourage you to talk to other people, especially about just understanding problems. And I don't mean don't use any online resources, especially if you're looking up general algorithms and understanding how they work and when to use them. That's great. That's part of the goal of this class, is to understand algorithms better. And so I'm not trying to say anything about that or tell you not to use that. If you ever have a doubt, then ask me or ask one of the TAs or use something from the book. Anything that we tell you is okay to use. So even if we tell you stuff that normally we wouldn't be able, if I tell you another person shouldn't be allowed to tell you that, well, guess what? If it comes from me or from one of the TAs, or if it's from the book, it's okay. It's better to err on the side of caution. So if you're like, I don't know, this feels kind of borderline to me, then just say that's a no. And then the other thing is, do not ask others to put themselves in compromising situations. I've sat on the honor council, and the cases I feel the worst about are when you have someone and they're friends with someone else and their friend asks them to help them cheat. And that puts them in a really bad situation, because it's like, hey, I'm asking you to be dishonest to help me out. That's like one of the worst things you can possibly do. That you're not being a friend to that person if you ask them that. So don't ever ask someone else to put themselves in compromising situations. In the bad event where you choose to cheat, at least keep your cheating to yourself. So, okay, hopefully that's enough. Hopefully I've made everything clear. And if you have any questions, please let me know. Don't forget to do the Canvas acknowledgement.